How are you, my friends? This is Calculus 1 solved questions. In this video, we'll see some questions about maxima and minima. Question number 1, find the maximum and minimum values of this function 5 times x to the power 2 over 3 minus x to the power 5 over 3 on the closed interval minus 1 to 4. So we have to check all the values in this interval. We start as usual by the derivative of the function. 5 is here, constant. Bring down 2 over 3, so it becomes 10 over 3, x to the power 2 over 3 minus 1, so it is minus 1 over 3, minus 5 over 3, x to the power 5 over 3 minus 1, remember the power rule, it will be 2 over 3 here. Now this one we can put it in the denominator. See, the idea here is to combine these two fractions any way you like. You can take common factor if you like. From algebra course, we have seen this. You can take a common factor, the smallest power, x to the power minus 1 over 3. That will work. And also, I will show you another way here. Put this negative power down. So it will be 10 over 3x power 1/3. And here we have minus 5. This is positive power over 3. Let's find the LCD here. The LCD, we have to multiply up and down here by x to the power 1/3. So we can here multiply. See the same base x, we can add the power. 2 over 3, 1 over 3. It will be 3 over 3, which is 1. So it will be 10 minus 5x. Take 5 as a common factor. So it becomes now the derivative f prime. 5 inside the bracket, 2 minus x divided by 3x to the power 1/3. Let's find the critical points of f, which are the solution of f prime is equal to 0, or f prime is undefined. So f prime is equal to 0, put this one is equal to 0, x will be 2. F prime is undefined when x is equal to 0. So there are two critical points. The critical point should be in this given in the domain here from minus 1 to 4. This is what we need. So now we can have a list. The endpoints of the interval, minus 1 and 4, and we have found 0 and 2. So there are minus 1, 0, 2, and 4. 4 values to check where is the maximum and where is the minimum. Let's see. So now we have the list. We call it the list here, minus 1, 0, 2, and 4 from the last slide. And this is the function. So I take each x from here, minus 1, I put it in the function here, f of minus 1, f of 0, f of 2, f of 4. And then you have to find the value here, 6, 0. This is not easy number, approximately 4.76, and this one approximately 2.52. So where is the maximum? The maximum is the 6 here. So this is the absolute maximum between minus 1. See, only we are taking from minus 1 to 4. This is the graph here. We are not taking the whole domain, just minus 1 to 4. So the maximum will be at 6, the absolute or the global maximum. The absolute minimum is 0 in these numbers, and these are local, max, local, min. Now, question number 2 is a good application on maxima and minima. We have a rectangle is inscribed in a semicircle. So we have to place a rectangle inside a semicircle of radius 10. So R is 10 for the semicircle. What is the maximum possible area of the rectangle? We need the area. Remember, the area of a rectangle is when you multiply the width times the length. Find the dimensions of the rectangle. That means find the length and the width. Now we start here by the area of a rectangle, as I mentioned, the length times the width, or the width times the length. It's the same. So the area can be 2x here. See, this is the rectangle, x and x. So this is 2x times the y. This is the width. So it will be 2xy is the area function. Remember, there are two variables here, x and y. So we have to find y in terms of x so that we can have the function only in one variable to find the derivative. So if you look at this right triangle here, see this is x and y, this is 90 degrees, and there is a radius here 10. So we can use Pythagorean theorem on the right triangle. X squared plus y squared is equal 10 squared, which will be y squared is equal 100 minus x squared. So y will be plus or minus square root of 100 minus x squared. We choose the plus because we are looking for the length and the width, and they should be positive. So now this is y, replace it here. See, the a of x, the area function of x will be 2x times y, so I put y here. Now look at this nice function here. A of x, 2x square root of 100 minus x squared. This is like a normal function like f of x, the functions we have seen before. Defined between 0 to 10. We cannot accept any value unless it is between 0 and 10. So the area is maximum if a prime is equal to 0 or a prime is undefined. So we need to find the derivative of this function. That's the application here. So a prime, there is a 2 here. Just take it outside, put it outside, leave it. Inside we have x times this one. So by the product rule, I think you remember, product rule will be u prime v plus v prime u. So the derivative of the x here is 1. The same here, square root of 100 minus x squared plus x at the end here, we put x. Then the derivative of this square root of 100 minus x squared, which is 1 over 2 square root of this times the derivative inside minus 2x. We have seen that the derivative is this expression here. Let's find the LCD, which is square root of 100 minus x squared. So we multiply up and down here by square root of 100 minus x squared. So we'll have 100 minus x squared minus x squared. It will be 100 minus 2x squared multiplied by 2. The final simplified derivative function is 200 minus 4x squared divided by the square root of this. Now a prime is equal to 0 or a prime is undefined. So a prime is equal to 0. We have 200 minus 4x squared is equal to 0. Take this on the other side, divide by 4, and then take the square root of both sides. X will be plus or minus square root of 50. A prime is undefined. If the denominator is 0, square both sides, x will be plus or minus 10. So let's put in the list all the values between 0 and 10. So we have 0, we have square root of 50, and we have 10. These are 3 positive values. And then let's apply this x to this area function that we have found. So we put 0 there, we put square root of 50, we put 10. A of 0 will be 0, a of 10 will be 0. A of square root of 50, when you put it there, it will be 100. Just try to simplify it. So the maximum area is 100. This is what we need. So what do we need now? In the B part, we need the length and the width. The length is 2x, remember from the diagram. It will be 2 times square root of 50. Now that's the answer here, but you can simplify it a little if you like. 2, leave it there, square root of 50, 25 times 2. Take 5 out, so it will be 10 square root of 2. The y, we have the equation for the y equals square root of 100 minus x squared. This is the y value. So it will be square root of 100 minus square root of 50 squared, which is square root of 50. Also, you can simplify that as 5 square root of 2. This is the width, and this is the length. Now let's look at question number 3, and be careful here, please. Given the function f of x, ln of x divided by x. That's the function. You don't have to graph it. The graph should not be given, but I put here the graph just to explain the idea. Find the coordinates. Look at the question. Find the coordinates, which means x and y, of the indicated local maximum point. So there is a maximum point on the curve in the first quadrant. You can just imagine that in the first quadrant for the graph, we have local maximum. So there is a point here. So I put the graph only so that you can understand and imagine. You don't need the graph. You can do the question without graphing, without even the graph is given. Find the coordinates x and y. You cannot get it even from the graph. If I give you the graph, let's say, you cannot get the point from the graph because you need the accurate. Now, solution is so nice. Let's find the derivative and put it equal to 0. So f of x will be ln of x divided by x. Use quotient rule. U prime v minus v prime u divided by v squared. So the derivative of ln of x will be 1 over x times the x minus ln of x times the derivative of the x, which is 1. So this is 1 over x times x will be 1 minus ln of x divided by x squared. So easy. So the critical points are when f prime is equal to 0. Put 1 is equal to 0. Or you can say also, and f prime is undefined, but 0 is not in the domain here because x cannot be 0 in the function ln of x divided by 0. So we take only f prime is equal to 0. 1 minus ln of x is equal to 0. 1 equals ln of x. So x will be e because we know ln of e is 1. So this is the x value. See, this is the x value in the first quadrant. Not easy at all. 2.7. F of e, just go to the function here. Ln of e divided by e. Ln of e is 1. So 1 over e. So look at the point here. Local maximum. E, comma, 1 over e. This is x and this is y. Now for more questions on maxima and minima, you can see lecture number 10. And for more questions on Calculus 1 in general, you can see Calculus 1 solved questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.